Hello and Assalamualaikum. My name is Muhammad Lukman bin Abu Hassan. My metric number is 01DKM20F1101. And I want to present about introduction. A gas turbine is internal combustion engine that operate with rotary rather than reciprocating motion. Gas turbines are compressed of three main components: compressor, combustor, and power turbine. The gas turbine mainly use Brayton circle to operate. The Brayton circle is a thermodynamic circle that describes how gas turbine operate. The idea behind the Brayton circle is to extract energy from flowing air and fuel to generate usable work which can be used to power many vehicles by giving them thrust. The most basic step in extracting energy is compression of flowing air, combustion, and then expansion of that air to create work and also power the compression at the same time. The usefulness of the Brayton circle is tremendous due to the fact it is the backbone in driving many vehicles such as jet, helicopter, and even submarine. George Brayton gas turbine was the first and most prominent fully operational gas turbine that implemented the Brayton circle. Gas is pressurized and held in reservoir A, where a valve would release it to move toward tunnel B and been ignited in chamber C. This is an isobaric process due to the fact any increase in pressure would just push the gas out of the engine when work is done to the D piston. Mechanical work can be improved for a variety of things such as the isobaric process due to the fact any increase in pressure would just push the gas out of the engine when work is done to the D piston. Mechanical work can be improved for a variety of things such as generation of electrical or movement, and there is also a piston in compartment E that such in atmosphere air from valve F. Valve G is a fitting to a fuel cell where the fuel to air ratio can be set so that a desired ratio for maximum efficiency is keep. The gas is then mechanical compressed back to reservoir tap, and a diabatic process due to the piston E. A quick qualitative look at how the Brayton circle works it by reviewing how a jet engine works. A gas turbine from a jet wing sucks in atmospheric air from the back of its engine, and its compressed is the combustion chamber. In the combustion chamber, fuel is mixed with the compressed atmosphere air where it is ignited and left to exit in the expansion chamber. The energy that comes out of the back of the gas turbine is work used to power the compression step as well as give thrust to the jet. So the brighter circle of the gas turbine circle has its own advantage and disadvantage. Let's look deeply into the advantage and disadvantage of the gas turbine circle.
Another introduction of gas turbine. A quick qualitative look at how the Brayton circle works it by reviewing how a jet engine works has its own advantage and disadvantage. So the advantage of the gas turbine is it is simple to design and construct compared to a steam power station since no boiler are required. Much smaller compared to steam power station of same capacity. Next, less water use since there is no need for a condenser.
Next, the maintenance charge below the small size of gas turbine power plant has made the maintenance work to be done in smaller scale. Thus, less money is required to make sure the maintenance of gas turbine power plant goes on frequently. Next, no standby loss by standby loss in a power plant are defined as the fuel wasted when no generation is happening. For example, in thermal plant, even a generator is kept standby, still the boiler should be run because it takes more than 24 hours to restart a boiler if it shut down. So the energy generated by this boiler which is not being used in the standby loss. In case of gas turbine power plant, no water is used. The boiler is no boiler and condenser. Therefore, no standby loss in this power plant. Next, we talk about disadvantage of the gas turbine cycle. Firstly, problem of starting. Compressor need to be operating, thus internal source of power is necessary. This causes some difficulties in starting the gas turbine power plant. Next, net output is low in a gas turbine power plant. Greatest power is used to drive compressor in the power plant. This causes the net input to be higher than usual, which makes net output of the gas turbine to start decreasing.
I will be presenting the next disadvantage of the gas turbine cycle. The next disadvantage of the gas turbine cycle is the overall efficiency of plant is low. The overall efficiency in gas turbine power plant is 20% because of exhaust gases still containing heat. The high quality of heat in these exhaust gases slowly decreases the efficiency of the plant cycle. However, this low overall efficiency is only efficient in a combined cycle configuration. The final disadvantage of the gas turbine cycle is temperature of combustion chamber is too high. High combustion power is required to heat up the gases. This causes the combustion power to become too hot. As the temperature of the combustion chamber increases, this results in a lower life of the gas turbine cycle. Now, I will be presenting the summary part of the presentation. Gas turbine working principle. Gas turbine engines derive their power from burning fuel in a combustion chamber and using the fast-flowing combustion gases to drive a turbine in much the same way as the high-pressure steam drives a steam turbine. One major difference, however, is that the gas turbine has a second turbine acting as an air compressor mounted on the same shaft. The compressor draws in air, compresses it and feeds it at high pressure into the combustion chamber, increasing the intensity of the burning fuel. It is a positive feedback mechanism. As the gas turbine speeds up, it also causes the compressor to speed up, forcing more air through the combustion chamber, which in turn increases the burn rate of the fuel, sending more high pressure hot gases in the gas turbine, increasing its speed even more. Uncontrolled runaway is prevented by controls of the fuel supply line, which limit the amount of fuel fed to the turbine, thus limiting its speed. Now I will pass my presentation to the final presenter of the presentation.
As the conclusion, gas turbine cycle have a numerous advantage than disadvantage. It is also necessary to use gas turbine cycle in power plants as this benefits the environment and the world. Lastly, it also helps to create a better future with a clean and safely surrounding.